Now let's look at the two DP approaches. So as you've seen, there are two DP approaches. There's memoization and there's tabulation. Starting with memoization, this is a top-down approach, and the concept is basically you start with the main problem, then you break it down into smaller sub-problems, but you do that recursively. And if a sub-problem has already been solved, you retrieve the results from a cache or or memory instead of recomputing that's a problem. So how this works is we use recursion to solve the problem, and we store the results in a dictionary or array after computing. So the next thing here is that, okay, let me just do this. So we store results in a dictionary, or an array. So that is memoization, and an example of memoization in using Fibonacci. Basically, let's go to here and write our code. So let's have a function, call it fib, and it takes in n, and it also takes in memo as its parameters, and memo is initialized to an empty dictionary. So basically check if n in memo, then we're going to return memo at index n. So let's return memo at n, should be an r. Then we're going to also go and check if n is less than or equal to 1, less than or equal to 1. If that is the case, we're going to go ahead and return n. I'm also going to go to memo at index n. This is going to be basically the Fibonacci. Understand how we calculate Fibonacci. So Fibonacci at n minus 1 plus Fibonacci of n minus 2. N minus 2. So fib of n minus 1 and fib of n minus 2. All right, then finally, we're going to go ahead and return. We're going to go ahead and return memo at index n. Then we can go ahead and just print the output here and see what you get. So if we print fib of 6, so if we enter the Fibonacci of 6, the output here should be 8, but let's run our code and see. So Python 3, this is memoization. Yeah, as you can see here, it gives us 8. So the key benefit here is basically it avoids redundant recursive calls, and the downside to this is that it may lead to some sort of deep recursion stack. Basically, it can cause a stack overflow if they are large, for basically large inputs. But that is basically how Fibonacci works with, or other memoization with an example of Fibonacci. Now let's go ahead and look at tabulation. Now, talking of tabulation, basically for tabulation, from what you've seen, the concept is that it builds solutions from the smallest sub problems to the main problem, and it uses an iterative manner to achieve that. So it stores its immediate results in a table, and usually an array, and we use those to build the final solution. How it works is we start with the base case, and we fill the table step by step, and we avoid recursion by iterating from smaller to larger problems. So that's ideally what you do here. And an example of this now in with Fibonacci with tabulation, just to show how that works, is so we just need a function fib, uh, fib of n, and with this function, so we need a table here, and what we're going to do is, so we're going to take index 0, Then we're going to multiply this by n plus 1. So n plus 1. Then we're going to take our table at index 1. Then we're going to assign this to 1. Then what we need to do is to do the iteration now. So for I in range, and the range is from 2 to n plus 1. What you need to do now, we're going to just assign here table at index I. We're going to assign this to it. So it's going to be table. Again, remember it's still Fibonacci, so the same method applies basically. Table at I minus 1 plus the table at I minus 2, like that. Then finally just go ahead and return the table at index n, like that. And just to check an output again, let's still use fib of 6. Should give us 8 as the output. So fib of 6, the output here should be 8. So let's go ahead and run this again. So Python 3, this is tabulation. Okay, what am I getting here? List object is not callable, table at I minus 1. Oh, okay, I should be using square brackets here, not parentheses. Same thing as this side here, because we're accessing the index of this element. Okay, so if we run this again, you see we get 8 as the output. Now, the key benefit of this is, of course, it avoids recursion and is a bit more efficient when it comes to larger inputs. And the downside for it is that it uses memory to store all the sub-problems, even when that is not needed, and that affects the space complexity. So just to look at it overall from what you've seen, the key differences between tabulation and memoization. Uh, Memoization uses recursion, and it's a top-down approach, and uses a top-down rather it's a top-down approach. So just right here, it's a top-down approach, uses recursion, and in terms of the execution, basically it starts with the main problem, then it boils it down. While when you talk of tabulation starts from the base cases as it builds up to the top. And in terms of space complexity, for memoization, it just depends on the the recursion depth, as we've seen, and how that affects our output. Then for tabulation in itself, we just use a fixed size table, and that's the beauty of it, even when it comes to larger inputs. And in terms of just performance, recursion has its own limits, so it can hit some recursion limits. But for tabulation, it becomes more efficient for large inputs for all the reasons that we've seen. Now, for tabulation, one of the main things we need to note here is that this one uses a bottom up. Then uses a bottom up, a bottom up approach. Starts with the base case, basically, as you've seen it, as it builds up, uses a fixed size table, and is a bit more efficient for large inputs. So I'll just say more efficient for large inputs as opposed to memoization, which has or rather which can hit some recursion limits basically. So a summary of what you've seen memoization stores results in recursive calls, tabulation, build solution iteratively from the bottom up. So that is it on the differences between these two main DP approaches. I'll see you in the next one.